Hello guys, how are you today? So today I'll be explaining the AS Physics past papers. We have 5 past papers. Let's start with the first one, which is 9702, paper 23, May, June 2025. We're doing questions 5A and B, only part I. In 5A, state why sound waves cannot be polarized. First of all, we know that sound waves are what are longitudinal mechanical waves, but for now we only write longitudinal. Why? Because when we are saying something is being polarized, it's transverse, and it can only be transverse for it to be polarized. So because sound waves are longitudinal, that means they cannot be polarized. So what do we write? We can write as the answer very simply that sound waves are longitudinal and because they are not transverse, that means, because they are not transverse, they cannot be polarized. Okay, so if you write this, you're supposed to get the full mark. So I think you can write polarized like this, polarized, or like this. Either way works. Now we move on to part B. What does it say? It says a plane polarized light wave is incident. Okay, plane polarized meaning it's polarized from before, is incident on a polarizing filter as shown in figure 5.1. They said that the light wave intensity initially is I0. So what does that mean? That means very simply that the intensity coming out of the polarizer is I0 as well. So what is the value of theta in this case? The value of theta is 0 degrees. Now, even though they said normally, why is theta 0 degrees? Because if you do cosine 0 degrees, you're going to get an answer of 1. And they said that the angle that the filter makes is how much? Is 90 degrees. Let's assume that this is our normal, right? And this is 90 degrees over here. This is the angle that the filter makes. Okay, so now if we go down, they said that the filter is now rotated through 360 degrees. So they changed it from what? They changed it from how it was initially at 90 degrees all the way until what? All the way until 360 degrees. Okay, so from 90 degrees, they went all the way until what? Until 360 degrees. Now, what do they need from us? They want us to sketch the variation of intensity I with the change of angle through 360 degrees. They gave us 1, 2, 3, 4, and 5 angles. Now, what should we remember? We should remember that what we said before was that the filter was at 90 degrees, right? And theta was 0 degrees, meaning what? Meaning that the intensity was the same before and after. Because of that, that means at 90 degrees, the intensity is what? The intensity is I0. Now that we have the basis point, which is the point we took from the graph, we can now proceed. So we can say, what is the theta between 90 degrees and 0 degrees? Theta in this case is 90 minus 0, which is 90 degrees. So now what do? We do I initial is equal to I initial times cosine squared theta, which is 90. And we're going to get an answer of 0, meaning that at 0, because they told us that we started at 90, meaning that at 0, how much was the intensity? It was 0. Let's now move on to 180. What is the theta between 90 and 180? It is again what? It is again 180 minus 90, which is 90 degrees. That means it's also 0 at 180. Now, what is the theta between 270 and 90? Very simply, you can do 270 minus 90, which is what? Which is 180. So the theta here is 180 degrees, right? So we're going to do I0 multiplied by cosine squared 180 you can do cosine 180, and you have to square the answer. Don't forget to square it. So you're gonna get I initial times 1, which is basically I initial. So at 270, the point is on top here. And now finally for 360, what is the difference in theta between 90 and 360? It's very simply 360 minus 90, which is 270. So theta is 270 degrees. So it's gonna be what? It's gonna be I initial times cosine squared 270. And you will get an answer of 0. So this is where the point is supposed to be. Now, if we join them, let me just get this so I can draw it properly. If we join them, it's supposed to look something like this. Oops, I don't know what happened. Okay, so let me just draw it without this then. Goes up, then down, then up, then down. So please, of course, yours has to be like better drawn than mine, but because I'm drawing on my tablet, it's a bit weird. So this is what the final answer is supposed to look like. So this is question 5A and B done. These are the answers. Okay, perfect. Now we move on to the next past paper, which is 9702, paper 22, October, November 2023. We're doing question 5, A and B. What did they tell us? They told us a beam of vertically polarized light, it's already polarized, is incident normally on a polarizing filter as shown in figure 5.1. So when they say it's incident normally, this means that I here initial is equal to what is equal to I1. So the I before is equal to the I after in the case they say incident normally. They told us that the transmission axis of the filter is initially vertical, meaning it's like this. Meaning it's what? It's 0 degrees. They told us the filter is then rotated at an angle of 360. So then it's rotated 360 degrees. And they told us what? They told us on figure 5.2, sketch a graph to show the variation of the intensity of the light in the transmitted beam with the angles shown below. So they said 0, 90, 180, 270, and 360. What are we supposed to do? We're supposed to find the initial angle, which in this case is how much? Is 0. Now we have to find theta for all of them. We know first of all that when it was 0, the initial angle, intensity initial was equal to intensity final. So that means this is the maximum value at 0. Now we need to do what? We need to find theta. In this case, theta is 90. Okay, so it's gonna be intensity initial times cosine squared 90, which is basically 0. Now, for this one, theta is 180. So you're gonna do I0 times cosine squared 180. And you're gonna get what? You're gonna get the maximum value, which is I0. Now, if you do theta for this one, theta is 270 because it's 270 minus 0. If you put it on the calculator, you're gonna get that the answer is 0. And now finally, what is theta here? Theta here is 360 degrees. So if you do I initial times cosine squared 360, you will get a final answer, which is what? Which is the maximum value, or I initial. So if you join it, you're supposed to get a graph that looks like this. Okay, this is AI done. We move on to AII. What does it say? It says the intensity of light in the incident beam is 7.6 watts per meter squared. Okay, so this is what? Intensity initial is equal to 7.6 watts per meter squared. When the transmission axis of the filter is at an angle theta, the light intensity of the transmitted beam is 4.2 watts per meter squared. So what did they do? They took I initial, they multiplied it by cosine squared theta, and they got 4.2 watts per meter squared. So I initial in this case is 7.6. So now you can move it to the other side. You will get that cosine squared theta is equal to 4.2 over 7.6. Let me just do it on my calculator. And you will get an answer which is approximately 0.55. So cosine squared theta is 0.55. That means cosine theta is equal to a radical 0.55, which is 0.74. So that means what? That means cosine theta is equal to 0.74. And how do you find theta? Theta is cosine inverse 0.74. Put it on the calculator. Cosine inverse 0.74. And you will get an answer which is approximately 42 degrees to the nearest integer. So that is it for this question. Let me just erase and keep the answer. Here we go. Now that is it for question A. Let's move on to question AB. State what is meant by diffraction of a wave. First of all, what is diffraction? Diffraction is when a wave passes through a gap or through an edge and then it spreads. So we have to say two things. What? The first one, I don't prefer to use gap because in the answer key they don't have gap as an option. The first one is that wave passes through an edge and then spreads. You have 2 marks for this question. So you're gonna have what? You're gonna have 1 mark for this and 1 mark for this. Okay, perfect. These are the answer key for this one. Let's move on to the next paper, which is 9702, paper 22, May, June 2023, question 5C. What did they tell us? They told us 2 polarizing filters are arranged so their planes are vertical and parallel. The first filter has its transmission axis at an angle of 35 degrees to the vertical, and the second filter has its transmission at an angle alpha to the vertical as shown in figure 5.2. Angle alpha is greater than 35 degrees and less than 90 degrees. A beam of vertically polarized, meaning it's already polarized, very important keyword, of intensity 8.5 watts per meter squared is incident normally on the first filter. Okay, so what did they say? Vertically polarized light, very important, of intensity 8.5 watts per meter squared is incident normally on the first filter. Now, show that the intensity of the light transmitted by the first filter is 5.7 watts per meter squared. Here they gave you the answer. How do we find the value of the answer? Very simply, we do I initial times cosine squared theta is equal to I1. In this case, I1 is equal to 8.5 times cosine squared 35. Put it on the calculator. And you will get an approximate value of 5.7 watts per meter squared. Okay, this is the first part. Now in part 2, the intensity of the light transmitted by the second filter is 5.2 watts per meter squared. Calculate the angle alpha. So we know what? First of all, we know that theta, in this case, is what? Is going to be alpha minus 35 degrees. Why? Because theta is the difference between this angle and this angle. Now, they told us that we have the value of I2. We also have the value of I1. And we need to find the value of alpha. Very simply, we know that alpha minus 35 is equal to theta. So what can we do in this case? We can write that I2 is equal to I1 times cosine squared theta. In this case, I2 is what? I2 is 5.2 is equal to I1, which is 5.7 times cosine squared what? Alpha minus 35. Now, move this to the other side. You're going to get what? You're going to get 5.2 over 5.7 is equal to cosine squared alpha minus 35. Now, how do you get rid of the squared? You will do radical for both sides. So this will be cosine alpha minus, this looks like a 2, but it's alpha minus 35. And then you will need to do a radical for this. So what will you get? You will get a radical 5.2 over 5.7, which is approximately 0.96, is equal to cosine alpha minus 35. So do cosine inverse on the side to get rid of the cosine from here. So now let's do shift cosine answer, and we will get this is approximately 17 degrees, approximately. So 17 degrees is equal to alpha minus 35. That means alpha is equal to what? Alpha is equal to 35 plus 17, which is what? Which is 52 degrees. So the answer over here is what? The answer over here is 52 degrees. And as you can see, these are our answers. We finished the third past paper. We'll move on to the next one. What do we have? We have 9702, paper 21, October, November 2022, question 4, parts A and B. Okay. Polarization is a phenomenon associated with light waves but not with sound waves. State the meaning of polarization. So the way we define in the exam polarization is what is changing unpolarized light into linearly polarized light. But the way in the AS level they want us to explain it is what? Is that oscillations are in a single direction, because as you know, unpolarized light is in all directions. So when you put it through a polarizer, it travels in a single direction, which is what? Which is perpendicular. Is perpendicular. This means perpendicular, right? The full word in the exam though. Perpendicular to the direction of motion. My bad, I thought I was recording this part, I forgot to record it. But anyways, light waves are transverse waves, meaning that they travel perpendicular to the direction of motion, meaning that they can be polarized, whereas sound waves are longitudinal, meaning they travel parallel to the direction of motion, meaning they cannot be polarized. Anyways, in all cases, let's move on to part B. What does it say? Two polarizing filters A and B are positioned so that their planes are parallel to each other and perpendicular to a central axis on line XY as shown below. Now, the transmission of axis of filter A is vertical and transmission axis of filter B is horizontal. Unpolarized light, very important, of a single frequency is directed along line XY from a source positioned at X. The light emerging from filter A is vertically plane polarized and has an intensity of IZ. So they told us what? We had unpolarized light, it went through the filter, and then it became, in filter A, it became what? It became I0. They said filter B is rotated from its starting point about the line XY as shown in figure 4.1. After rotation, the intensity of the light emerging from filter B is 1 over 4 I initial. Calculate the angle of rotation. So again, this just requires a bit of math. We know that I initial times cosine squared theta is equal to what? Is equal to I final. In this case, I final is what? I final is 1 over 4 of I initial. So what can we cancel? We can cancel from both sides, I initial and I initial. So we are left with what? We are left with cosine squared theta is equal to 1 over 4. So how do you get rid of the squared? You're going to do a radical for both sides. So cosine theta is the square root of 1 over 4, which is 1 over 2. That means theta is equal to cosine inverse of 1 over 2, which is what? Which is 60 degrees. But we have what? We have that theta is 60 degrees. But we can get also other possible values. How? By adding 180, so you will get 240 degrees. Now, another thing you need to know is that we can also do 180 minus 60 to get what? To get an answer of 120 degrees. That works. And then to the 120 degrees, we can add 180 to get 300 degrees. So how many possible angles do we have? We have 1, 2, 3, and 4 possible angles. But is this what they want from us? No, they want the angle of rotation. Us, we got what? We got the value of theta, which is the difference in between the previous angle and the current angle. So you could choose any value, okay? For example, let's say you chose 240, okay? You choose 240 and you subtract it from what? You subtract it from what they told us. What did they tell us? If you go up, they said that perpendicular to the central axis xy. And when they say perpendicular, this means 90 degrees. So that means you will go back down and you will do 240 minus 90, which is what? Which is 150 degrees. Of course, this is one of the many possible answers. You can choose any value you want and you could substitute. So you could say 120 minus 90, which is 30 degrees, that's also correct. Or 300 minus 90, which is 210 degrees. But in all cases, they are all correct. As you can see, this is the marking scheme for this question. And now we'll move on to the final question, which is what? Which is 9702, paper 22, October, November 2022, question 5C. So what are they telling us over here? They told us a beam of vertically polarized light of intensity I0 is incident normally on a polarizing filter that has its transmission axis at 30 degrees to the vertical. Perfect. So now we know that this is 30 degrees, right? And what is the key term? That it's polarized light. They told us the transmitted light from the first polarizing filter has intensity I1. Then the light is incident normally on a second polarizing filter that has its transmission axis at 90 degrees to the vertical. The transmitted light from the second filter has intensity I2. They want what? The ratio of I1 over I initial. I initial, we're gonna call it I initial. And now I1. I1 is equal to I initial. What did I write? I initial times cosine squared what? Cosine squared theta, which in this case is 30 degrees. So they want I1 over I initial. So it's I initial times cosine squared 30 degrees, which is I1 over I initial. You can cancel this and this, and you're left with cosine squared 30 degrees, which is what? Which is 0.75. So I1 over I2 is 0.75. There's no unit because it's a ratio. Now, I2 over I initial. I2 is equal to what? Is equal to I1 times cosine squared what? Cosine squared theta. What's theta in this case? This is 90 and this is 30. So theta is 90 minus 30, which is 60 degrees. But they want it in terms of I0. So what is I0? What's the value of I1 in terms of I0? We took it before, which is what? Which is I0 times cosine squared 30. So basically it's I0 times cosine squared 30, which is I1, times cosine squared 60. Now this is what? This is all the value of I2 over I initial. This and this will cancel, so the final answer is cosine squared 30 times cosine squared 60. You can put it on your calculator. Cosine 30 squared times cosine 60 squared, and you're gonna get an approximate answer, which is what? Which is 0.19. So that approximate answer here is 0.19. And this is the marking scheme. Thank you guys for watching. I hope you enjoyed and have a wonderful day.